Problem 8. In this tutorial we will determine the grain size from the photomicrographs. So in this problem, the statement of this problem is using the intercept method, determine the average grain size in millimeters of the specimen whose microstructure is shown in figure 4.15b. So here on this left side, this is figure 4.15b. Use at least 7 straight line segments, and in part B estimate the ASTM grain size number for this material. So you have this micrograph. So to do this problem, well, you can do one of the two things. So maybe first thing is that maybe you can do is you can take the printout of this and then manually draw the lines. So considering this scale, so if you take this much length equal to 100 micrometer, so you can convert it into the millimeters. So then you can draw lines according to this, so in millimeters. So for example, if you print it and then you can draw the lines, maybe each line is like 60 millimeter. Or the other way is that to draw the line using some drafting tool, okay, computer such as AutoCAD or any other suitable approach. Anyway, so you need to draw at least 7 straight lines, and then there is no specific pattern in which you should draw it. Rather just distribute them randomly, okay, or in these lines should not be drawn like not too much on one side, so just random, almost uniformly distribute in different directions. So as you can see that the lines have already been drawn and these lines have been numbered. So next step is to count the number of intersections for these points, for these lines with the grains. So as you see that the grains have been shown, some grains are bigger, some grains are small. So you need to count the number of intersections. So for example, for this line 1, the number of intersections can be counted as starting from here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Okay, and similarly for line 2 is here. So the number of intersections can be counted. So for 2 there are 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and maybe I have missed one, so there is another one is 10 over here. So the number of intersections should be counted. So let's suppose the number of intersections are, so after the number of intersections will be counted, so these can be represented over here. So the line number 1 and number of intersections. So line number 1 I have already counted, so line number 1 will have 11, line 2 will have 10, 3 will have 9, 4 will have 9, 5 will have 7, 6 is 10 and 7 is 8. So after this you will add up all these intersections. So if you add up all these intersections, this will be 64. Remember that it depends on how you draw the line. So these number of intersections may be different, so your answer may be different than this, but of course uh, you cannot expect a lot of difference. Okay, so the next step is to find the um, average grain size. So average grain size we have to find. So average grain size can be found from this equation. L bar is equal to L sub t divided by PM. So where L sub t is the total length of these lines. So it was assumed that each line was 60 millimeter. Okay, each 60 millimeter line was drawn. So there are 7 lines, so it will be total line length is 420 millimeter, and P is the total number of intersections. So P is the total number of intersections, boundary intersections. So here we have 64. M is the magnification. So magnification will be given, although it is shown as 100 micrometer, but in the book its magnification is already mentioned as 100x. Well, remember that this is not the magnification. Magnification will be given. So since this book problem is from the book, so in the book the magnification is given as 100x as well. Well, magnifications can be found from this as well. So for this we need to measure it. So magnification can be also found from here as well. So anyway, the magnification is 100x. So we will put 100. So now you will put all these values to find L bar, and L bar is the mean intercept length. So mean intercept length is the measure of the grain size. So the 420 divided by 64 multiplied by 100. So you will get a value of about 0.066 millimeter, because these are the unitless terms. So this is millimeter, so 0.066 millimeter. So you can see that the average grain size will be about 0.066 millimeter. Okay, part B says that estimate the ASTM grain size number for this material. So ASTM, American Society of Testing and Testing Materials, has given a formula for the grain size number, which is represented by G. So this formula is minus 6 points. This is an empirical formula, 6.6457 log L bar, okay, log L bar minus 3.298. Okay, so this is an empirical formula, and the units of L bar should be in millimeter. Okay, if the units are some other quantities, these units must be converted into millimeter to use this formula, because this is an empirical formula. So now only one value we need to put, which will be L bar. So this value will be input over here, and then you will calculate it using the log. So this is the log of base 10. It is not any other log. It is log of base 10. So you will get a number which will be equal to, if you input this number, so the answer will be, so the value of G will be 4 4.55. So this will be the ASTM grain size number for this question.